Okay, so in this video, I'm going to go over some common air sealing trouble spots and what to do about them. This kind of follows up on the building construction lesson and then the air movement lesson. And so this, we're going to kind of put those two together and look at some areas focusing mostly on residential buildings where common leaky spots are and sort of how you fix them. Okay. So as a quick reminder from the previous lesson, remember that we're constantly dealing with air pressure changes inside of buildings. We have the stack effect, we have wind effect, we have um, combustion effects where the furnace is removing air from the building, we have ventilation fans. Um, and so just remember that anytime you move air away from an area, it lowers the pressure. Anytime you move air toward an area, you increase the pressure. Okay, and remember with the stack effect, um, you have the air that's moving up because of warm air that's rising, all right, and that creates high pressure zone up high, low pressure zone down low, and then up high we have high pressure with respect to the outside, and so it's going to push out. In the bottom lower parts of the building, you have low pressure with respect to the outside. That's going to suck air in. So you can actually, on a really cold day, you may feel a draft along the floor of a building if there's particularly leaky spots, and that's from the air being sucked in because of the stack effect. But you can change pressure with a furnace, which is removing air out of a building, an exhaust fan, even a laundry fan will change the pressure in a building. And just remember, as an absolute rule, that for every cubic foot per minute that goes out of a building, a cubic foot per minute comes back in, and vice versa. So if I'm bringing in 500 cubic feet per minute with a ventilation fan, then that means I'm spitting, I'm ejecting 500 cubic feet per minute as well. And then we talked a little bit about a blower door and how that will enhance. It depressurizes a house on purpose or a building on purpose, so you can pick up on all the various small leaks in the building. Okay, so in general, when we're looking for air leaks, the most common place for air leaks is where two or more surfaces meet, right? So a wall meets a ceiling, or the band joist meets the subfloor, whatever. Okay, and so remember that where they meet, those edges are where there's opportunities for infiltration and exfiltration. And also, just in general, if you have more surface area, you're going to have more heat loss just because of the UA delta T equation. So just some examples here. This is common in older attics. It's not common anymore, but this is actually a crawl space up here, okay? And you can actually see inside of the walls. This is an old plaster. You can actually see the plaster and lath on the inside of the wall here. And so that's obviously a big problem because that's your building envelope, right? So dealing with the envelope would go down here and back up here, right? This is all part of your envelope. So there's a couple really big problems with this. Number one, that's the inside of the wall, so there's no insulation, so that's exposed wall. That's probably an exterior wall. So this is unconditioned up here. So you're leaking that. Secondly, you have a lot of extra surface area, right? So you have this surface area, this surface area, this surface area, this surface area, all of that, and that's heat loss, right? Plus you have all of these additional areas where these building surfaces meet that could be air, not only heat loss, but air leakage as well. So what do? Seal it up, right? So now what we've done is we could seal across here, just use some foam board, maybe some supports, put some, this is a different attic, but it's a good example of what you would do. Just put foam board across and then spray foam around it. And then what you've done is you've made this then the thermal envelope, right? So you've minimized your surface area, you've minimized the area for leakage, and the foam is great because it acts as both an insulator and an air sealer. So if you have pulled down attic steps, big trouble spot, okay? So a couple things you want to do. Number one, you want to weather strip. It just depends on which side. So this is actually the the latch or the hatch kind of goes up. So you want to have in this case, or weather stripping on the inside, and that creates an air seal. So weather stripping just air seals. It doesn't really insulate. It's a bit of insulation, but that's not what it's for. It's for air sealing. Now, if you have pulled down attic steps, you want to weather strip inside here, weather strip right there. So that forms a nice tight seal, and you want to have a nice tight lock. Other things you can do, you can put a cap over top of this. So this is actually a removable like nylon cap with some foam insulation on it. And this is actually zipper here. And so what you can do is you can put that over top, because just imagine, the drop down steps, it's really difficult to insulate that very well. So what some people will do is they'll put a cap over top for insulation and air sealing, so that way you don't really have to insulate the steps. And this is just a diagram of a couple different ways to insulate attic steps. So this is a scuttle cover. That's where this is a panel that you put down like that. And so here you want a weather strip here and here to form a nice tight seal. And then for this, this is obviously goes up like that. So I would also weather strip right here as well as here and here. Okay, you want to make sure those gaps are nice and sealed. And this is where you can put a box, like a cover over the top like this, right, with some insulation. Okay, so that's really important, weather stripping attic steps. Other common trouble areas, especially in older homes, this is not such an issue in new homes, is a lot of times in these older homes, actually behind the porch roof, you'll notice it could be even wide open. And so you want to seal anything up there. Again, this is just another surface where they're meeting. It's just an opportunity for infiltration. Anytime you have extra surfaces, you're upping the opportunity for infiltration, and you're also increasing the surface area. So if you think about this, the flat side of the building as opposed to a bay window, think about all the extra edges that you have there, right? So you have an edge here, edge here, edge here, edge here, edge here, and so on. There's edges up here, there's edges down here. And so that's just offering opportunities for air leakage. Okay, so you got to be really careful about sealing those. And again, this is extra surface area as opposed to the flat wall. And so that's extra heat loss as well. Lots of extra edges there. Tuck under garages. So if you have a garage underneath living space, you want to make sure that's very tightly sealed, because people store chemicals in the garage. They park the car in the garage, which has toxic fumes. So it's really, really, really important that this is very tightly sealed. You also want to have it insulated above the garage as well. Another really common thing, you see a lot of this in Delaware, where you see these cantilevered floors to give you extra floor space. And you'll see this in a lot of buildings in Delaware, a lot of residential buildings in particular. And so what does this do? It does two things. Number one, it adds surface area, right? So that's more heat loss through the surface. Number two, it offers the opportunity for air leakage, because you have another edge here meeting an edge here. And so you want to put a nice tight air seal like this, insulate it really well. You can put some foam board in there. You'll notice in a lot of these buildings, if you've ever had a house with a cantilever, that it's probably cold right over the spot right here, because that's generally not going to be as insulated as it should be. Recessed lights, as long as it's protruding up into an unconditioned space like an attic, a lot of them look like this, right? No insulation around it, no air sealing around it. So if you look at these under an infrared camera, you'll see this is leaking air all over the place. It's a cold spot. So there's a couple things that are important. So you should not put insulation over top of recessed lights unless it's an IC rated fixture, okay, which I think stands for insulation contact, but I'm not sure. So if it's IC rated, now they're more expensive, but it will say IC on it somewhere, then you can put insulation right on top. If it's not IC rated, it's just a cheap, whatever, $10 recessed light fixture, then you can't put insulation on top because it's a fire hazard. So what you need to do is you need to give 3 inches of space on every side. Okay, so 3 inches here, 3 inches here, 3 inches above it. Okay, and then if you do that, then you can put insulation on top of that, right? So that's what this does down here. That actually, you can build your own job-built box, some foam board or some drywall, tape it up, or get some foam, tape it up, or use some spray foam. And as long as there's 3 inches on all sides of this light, you can just dump insulation right on top of that. Okay, so that's another really common trouble spot. So just remember, when you're looking for leaks in a building or house, you want to look for where edges meet, and that's where a really good opportunity for air leaks. So anytime 2 or more building members meet, that's where you want to look. And there were some videos posted on the class website that show you some common ways of actually demonstrating how to fix some of these air leaks.